Hey, and today we'll be talking about the derivative of e to the power of x. And what you will see is that the derivative of e to the power of x is e to the power of x. And this is just another special thing about e and its properties. But basically, if you don't want to watch the proof, I guess the only thing you have to know is that if you have a function where f of x is equal to e to the x, then f prime of x is also equal to e to the x. So the function itself is equal to the derivative of it. So if you think about it, at each point where the function is, that's the exact same slope that the function has, and that's quite interesting. Alright, and for those of you wanting the proof, this is the video for you, because this is exactly what I'll be doing right now. And the proof is pretty simple and straightforward, but it's actually quite interesting. And to do it, we have to think, what is a derivative, right? What's the basis of a derivative? And if we remember correctly, it's a limit. Every derivative is a limit. And sometimes we simplify those limits so we can have a more generalized rule, as calculating the limit can get quite hard, quite time-consuming, and we want to look for a generalized formula for some common expressions that numbers can be written as. Alright, so how can we go about this? So first, let's write this out as a limit, right? So the derivative of e of x would be equal to the limit as delta x approaches 0 of e to the power of x plus delta x minus e to the power of x over delta x, right? And now we have to look for something to simplify, right? So we can get to e of x and prove our finding. Alright, so what can we see here? Well, we can see that over here, this is similar to, for example, when you have a to the power of b plus c. And based on our power rules, this is the result of ab times a to the power of c, right? So what can we say about this? Well, we can rewrite this as the limit as delta x approaches 0 of e to the power of x times e to the power of delta x minus e to the power of x over delta x. And you might be looking at this and you might straight away realize that there's a common factor in the numerator. And what we do to common factors is that we factorize them to make the expression simpler so we can simplify it. Alright, so then we have the limit as the delta x approaches to 0. And then you take the u of x out because that's a common factor in the denominator, times e delta x minus 1 over delta x. And when it comes to limits, the only thing that's important is something that has this part in it, the delta x, right? Because nothing else is going to be affected. If there's no delta x, then the expression will be affected. So what we can do is we can take out the e to the power of x out of the expression, right? Because it doesn't matter if delta x goes to 0, e of x will still be e of x. So we have e of x times the limit as delta x approaches 0 of e to the power of delta x minus 1, all of that over delta x. Now this was the pretty simple part. To move forward, we're going to have to introduce a substitution of variables. And our substitution of variables is going to be, we're going to use n, where n is going to equal to e to the power of delta x minus 1. And then if we rearrange this, we have that n plus 1 is equal to e to the power of delta x. And then we have that the natural log of n plus 1 is equal to delta x, because the natural log of e to the power of delta x is just delta x, right? These are a rearranged equation that we will use. And now, to rewrite the limit, we can have our limit equal to e of x, the limit when delta x approaches 0, which equals to n, right? N is e to the power of delta x minus 1, over, and we need a delta x, so over natural log of n plus 1, right? Makes sense? But now we have a delta x in the bottom of the limit right here, but we don't have a delta x anywhere in the equation. So that doesn't really make sense. So we have to figure out what to put instead of the delta x. And as we look, we can say that as delta x approaches 0, that also means that we can see that n equals 0. Right? So we can rewrite this as n approaches 0. This can be seen from this equation right here, by the way, if you're wondering. Or actually all of them, but this one is the clearest, where e to the power of delta x, when that goes to 0, when delta x equals 0, e goes to 1 minus 1, that's just 0. Alright, so this can be written as e of x times the limit as n approaches 0 times n over the natural log of n plus 1. Now, what we're going to do next is we're going to multiply this by 1 over n over 1 over n. And this is just to get rid of the numerator. And this equal to 1, right? Whenever you have a over a, that's 1. And in this case, a can be viewed as 1 over n. Alright, so what does this simplify to? Well, this can be written as e to the power of x as a limit of n approaches 0 of n times 1 over n, well, that's just going to be 1, right? Times 1 over n times the natural log of n plus 1. Yep, checks out. And what we can look for in here is, how can we rewrite this? And we can rewrite this using a natural log property. And the one that I'm talking about is where you have a times the natural log of b, for example. You can rewrite this as natural log of b to the power of a, right? And we can use this right here. We can use this and rewrite this as e to the x times the limit as n approaches 0 of 1 over, and instead of writing this out, we can write this out as the natural log of 1 plus n, this is the same thing as n plus 1, by the way, to the power of 1 over n. Right, so had to start a new page right there, but what can we look at this and how can we further simplify this? Well, if you look at this, you can realize that the natural log isn't affected by n, so you can take that out of n as well, and you get e to the x as 1 over the natural log as the limit of n approaches 0 of 1 plus n to the power of 1 over n, right? Now this is a pretty long fraction if you ask me. And this might look familiar to some of you who haven't forgotten a property of e, but I'm just going to remind you that another cool property of e is that, and this is a limit property, is that e actually equal to the limit as n approaches 0 of 1 plus n to the power of 1 over n. And would you look at that? This is exactly what we have right here. No coincidence, by the way. And so how we can rewrite this as, and this is like our final step, well, almost final step, e of x over 1 over the natural log, and all of this, as you can see here, this is just e, the natural log of e. Now, what is the natural log of e? The natural log of e is 1. So we have e to the power of x over 1, which is, come on, this is just 1. And we get e over x. So all of those steps that we just did got us right here to e over x. And I hope this got you some clarity on where this comes from, and I hope you're fascinated by e even more now, because it's really fascinating if you think about, you have a graph, and the point on the graph is the slope of the graph. That's pretty cool. Anyway, I hope you enjoyed this proof, and I hope you got something out of it. Maybe just you're interested in it, or maybe this helps you understand derivatives better. And see you next time.